Hello everyone and welcome to part 4 of making a cloud game. By the end of the third video, we had the automatic game joining of the two players. In this video, we will modify most of that code to suit the game better, and we will also be adding a feature that will display the squares right at the beginning. Before we proceed, if you have not watched parts 1, 2 and 3, then make sure you click the card up here to watch them right now. Great, with that out of the way, we can begin writing some code. First, we must recreate all the auto game leaving code in the player sprite. I will explain the reason for doing this a little bit later, just follow me along for the moment. So we go into the player sprite and create a variable called D for this sprite only. This variable will function the exact same way the offline variable did in the opponent sprite. We set D to 0 right at the beginning. Okay, we can now perform the operations in the main forever loop. Depending on whether the myPlayerNumber variable is 1 or 2, we will program two slightly different scripts. If myPlayerNumber is 1, then we check if D is equal to 0. If yes, we set last value to the joint value of A and P2. Outside the if then condition, we change D by 1. Nice, we can now check if D is equal to 100. If yes, then we check if the last value is the joint result of A and P2. If this is true, then it means that the opponent has left the game, so we set P2 to blank and switch backdrop to waiting. Finally, we set D to 0. I'm not going to explain what we're doing here because this is pretty much the exact same thing that we did in the opponent sprite in part 3. Great, we have completed the case where myPlayerNumber is 1. Now we have to program the case where myPlayerNumber is 2. There are a few changes that we need to make to the duplicated code. We simply change all the P2s to P1. Now that we have done this, we go into the opponent sprite and throw in the getCloudData4 function, the begin decoding of function, and the getNextValue function into the player reader sprite. The player reader will receive all the appropriate cloud data such as the username and the square content and display it on the screen. Okay, now we can delete most of the scripts involved in the opponent sprite, starting with the start game message. We can throw out the tick custom block, the getNextValue function, and the begin decoding of function. Once you clean up the scripts, you should be left with just 4 remaining scripts. Since the opponent cat is no longer required, we can go into the costumes tab and delete it. We do the same thing for the player sprite, which is go into the costumes tab and delete the cat. Perfect. With this done, we can start receiving data in the player reader sprite. The first block of code is the start game message. Now, when this message is received by the player reader sprite, we need to perform a series of steps extremely fast. To allow for this, we create a custom block called updatePlayerVariable, making sure to run without screen refresh. To show the usernames on the screen, we create two variables, player1 and player2, both for all sprites. Since we will not be hiding these variables, we can position them at opposite sides of the top of the stage. Alright, let us now program the start game message. At first, we wait for 0.2 seconds and within a forever loop, update the player variable. Within the custom block, we first get cloud data from 1, then we check if value is not blank. If this condition is true, then we will begin decoding of value, and after this, we will get next value. At this point, the value variable is storing the username, so we set player1 to value. If the condition is false, then we know that the opponent's slot is empty, so we set player1 to blank. Okay, this is what we have to do for player 1, so it should be no surprise that we have to duplicate the code for player 2. Right, so we change cloud data to 2. Next, we set player 2 to value and also set player 2 to blank. Nice, this is all you have to do for the game joining mechanism, but it is going to be quite boring if the whole stage is blank. So we will also set up the starting squares so that when the player and opponent enter the game, they will see the starting empty tic-tac-toe board. For this, we head over to the initializer sprite and create a custom block called setupSquareList. There is no point defining this function if we don't use it, so we put it in the main script. We don't actually have a list to set up at this point, so we create one for all sprites called SquareList. The square list will contain the value of each square in it. I will explain this in detail in the next video, but for the moment just keep in mind that the list will have 9 empty elements, each corresponding to a particular square. Alright, at the start we will delete all the elements in the square list. We need 9 empty elements, so within a repeat 9, we add a blank to square list. Okay, now we can move on to the square sprite. If you take a look at the costumes tab, you will see 3 costumes: blank, X and O. Initially, the squares will all be blank. When player 1 clicks on a square, it will become X, and if player 2 clicks on it, it will become O. In order to set up the squares so that they all display like a board, we need a few more variables. The first one is called startX for all sprites. Then we create another variable called startY also for all sprites. Great, we can now hide those 2 variables. When the green flag is clicked, we set startX to -75 and startY to 85. We finally hide the sprite. When the start game message is received, we wait for 0.4 seconds. We then create a new custom block called createClones, making sure to run without screen refresh. We put the createClones function right after the wait lag, and now we actually have to define it. We first move to the front layer and then switch costume to blank. We now have to create a few more variables. First, we create one called clone for this sprite only. Then, we create another variable called inside for this sprite only. Then, we create another variable called square number for this sprite only. Lastly, the 2 final variables are called X and Y, and we set them both for this sprite only. I will explain how each one of these variables work and what their purpose is, but first we need to hide all of these newly created variables so that they don't clutter up the screen. Alright, let's start with the easiest ones. The square number is like a clone ID. It merely stores a number that is unique for each square. If we were to visualize a board, then the top left square will have a square number of 1, while the bottom right square will have a square number of 9. The inside variable stores what is on each square. If the square is blank, then inside would also be blank. If the square is an X, then inside would be X. If the square is an O, then inside would also be O. The remaining variables like startX, startY, X and Y deal with the position of each clone. StartX is the X coordinate and startY is the Y coordinate of the top left square. If you think about it for a moment, it is very easy to calculate the coordinates of each square. If we assume that the side length of each square is S, then the X and Y coordinates of each square would be as follows. To allow for a general formula of the coordinate, let us assume that each square is assigned an ordered pair X, Y. As you probably guessed, the variables X and Y are used for this very purpose. If we assume this, then the general formula for the coordinates of a square would be as follows. The X coordinate would be startX plus X minus 1 multiplied by A. The Y coordinate would be startY minus Y minus 1 multiplied by A. If you're not convinced, then try substituting the X and Y values of each square and you should get the same result. Okay, let us now actually write the script. Since we're creating clones, we set clone to yes. We set inside to blank and square number to 1. For the X and Y variables, we need to use a nested loop. First, we set Y to 1 and within a repeat 3, set X to 1. We add another repeat 3 and inside we create a clone, change X by 1 and then change square number by 1. Outside the inner loop, we change y by 1. Now the scope and working of nested loops is beyond this video, but essentially this results in exactly what we want. Since the variables are private, each clone has its own copy of x, y, square number, clone, etc. When a new clone is created, we show it and go to x, start x plus x minus 1 multiplied by 75 and y, start y minus y minus 1 multiplied by 75. I explained this derivation in detail. The only new thing is that the side length of the square has been replaced by a numerical value of 75. Since each square has its costume stored as a corresponding element in the square list, we switch costume to item square number of square list. We also constantly update the inside variable to the same value. And that is all you have to do for the program. If you test out the auto game joining mechanism, it should work perfectly, and you should also have the initial square arrangement show up. With that said, thanks for watching, and I will see you in part 5.